Okay, before I begin my this particular next topic or this video, I want to just mention one thing, that in the previous video just you have seen or you have completed, one thing I had mentioned wrong. Here I had said dry ice. It's not dry ice, it's ice. It's not about dry ice. You see, in case of hydrogen bonded molecular solids, bonding between a molecule of hydrogen and oxygen or hydrogen and nitrogen should be there. Hydrogen has to be there for hydrogen bonding, and dry ice is CO2, so no, that is not the case. However, in case of CO2 there is dipole-dipole interaction, and another thing I want to mention is the dipole-dipole interaction is much stronger than London force, and hydrogen bonding is much stronger than dipole-dipole interaction. That I must have mentioned. And the other thing, that this kind of covalent network, please don't confuse it with the covalent bonding present here. Okay, these are covalent bonding between the atoms forming the molecules, and here the forces that I have mentioned is the forces between those molecules which are already covalently bonded. Okay, and between them the force which holds them in a solid state, that I have talked about, this London force, dipole-dipole interaction, or the hydrogen bonding. And here the particles of the atoms are being held by covalent network, forming a giant molecule. Okay, forming a giant molecule. These molecules are giant molecules. Okay, all carbon are only linked, same atom are only linked. So I hope that there shouldn't be any confusion regarding that. After now, as you have understood up to this much, I will move into our next topic. And what is our next topic? Our next topic is understanding the space lattice or crystal lattice and a unit cell. Understanding about space lattice or crystal lattice and unit cell. Unit cell's other name is crystal habit. Crystal habit. So from this you know that previously also I said you that what is the meaning of having a crystal structure is to have a perfect definite geometry. Now, so that means space lattice. Now I'll shift my camera to a diagram which I had showed you before also. A space lattice is a proper geometrical three-dimensional arrangement, okay, formed by motifs. Motifs are the units. Which will together repeat. The motifs will repeat and form the crystal lattice. Okay, and form the crystal lattice structure. So suppose, for example, if you think that this is an arrangement of one type, and suppose this is a motif, okay, this unit will repeat. So if you place it as a particular arrangement like this, continuously, if you keep on placing it in lattice points, these are the lattice points, okay, then it will create a three-dimensional structure. Now what kind of it is very tough to determine or visualize from this that what kind of three-dimensional structure it will create. You have to imagine lines between them, and when you will start imagining lines between them, you will find the lattice structure. Okay, so I told you I am very poor in drawing. Anyway, the motifs are repeating. I hope that you can visualize it, and they will form the motifs are repeating, and they will form the crystal structure, and the crystal structure will be forming having crystal lattice or unit cell. Now first we have to understand about the unit cell, which repeats, which continuously repeats, which creates the long, which repeats, and in the crystal structure we said that having long range order because the unit cell repeats or the crystal lattice structure entirely repeats. Now what happens, I'll shift my camera to a diagram. You see, in this diagram you can see what is there in this diagram. Previously also you have seen, this is a unit cell. This is a cuboidal cell, I understand that. Okay, not a cuboidal but a cubical. This is little bit less. Okay, cube and cube. A cuboid kind of structure. Okay, a cuboid kind of structure is there, and in this cuboid kind of structure you can see that this structure is continuously repeating. So this entire structure is known as a crystal lattice, and this is the unit cell or crystal habit. Okay, the crystal habit repeats continuously one after the other. If you imagine this crystal habit, it repeats backwards, forwards, sideways, backwards, upore, niche, everywhere it will repeat and create a entire crystal structure. See what is written here. The smallest, see, I'll focus and I'll show you what is written. The smallest three-dimensional portion of a complete space lattice. This is a complete space lattice. Okay, this is a complete space lattice. Now what did it say? The smallest three-dimensional portion of a complete space lattice, which when repeated over and over again is different directions, produce the complete space lattice, is called unit cell. So this is repeated over and over again in different directions, সামনে পিছনে পাশে উপরে, okay, নিচে, on all the directions it is repeated, and hence it is known as the one unit cell, which is continuously repeating this side, that side, this side, that side, and creating the entire space lattice. So what is a space lattice? Such a regular arrangement of the constituent particles or atoms or ions of a crystal in three-dimensional space is called crystal lattice or space. So you know, where are the particles? You can imagine that in this place are the particles. These are the particles, these are the particles, these are the particles, these are the particles. So particles, and you can imagine them as the line of force. However, for right now you can imagine like this. Okay, these are the particles, and continuously these particles are repeating with a perfect geometry, forming a unit cell, okay, which is repeating itself, forming an entire crystal lattice, space lattice. So this is a space lattice. So I hope that you have understood what is space lattice and what is crystal lattice, and what is space lattice you have understood, and crystal lattice you have understood, and what is unit cell. I hope you have understood what is the unit cell. So that is the thing. You can read from here, you can take a screenshot of this also, and you can read from here. This is very easily written. So I hope that you have understood whatever I have tried to explain. Now let us try to understand about the types of unit cells that may be there. Okay, I hope that you have understood what is unit cells just now. Okay, the repeating units which forms the crystal lattice or the space lattice. The space lattice is the uniform geometrical structure, and one unit will continuously repeat in all directions, samne pichone upor niche, and that those are the unit cells like the diagram you have seen here and you have understood here. Okay, so that is the thing. Now moving forward, we will understand that only that you think that if this kind of cuboidal unit cell will only be present always in all kinds of crystal lattices, thinking that will be too wrong, because there can be various types of unit cells, and the type of unit cells will depend on the dimensions of these, okay, the length, breadth and height, and also the angle between them. Okay, I will show you. Suppose for example, if you think that it is a simple lattice, okay, what kind of lattice should you say it? I am preferring to say it a cubic lattice. It is cubic because this side is A, this side also I will take A, cubic unit cell. Okay, this side is also A, this angle is considered as alpha, the angle between this A and this one, okay, is alpha. The angle between this one and this one is considered as beta. Okay, so these two angles, so this and this, and there will be angle between this and this. Okay, wait, there will be angle between this line and this line. Let us take this as gamma. So it is like this. So this angle is gamma, this angle is alpha, and this angle is beta. So here three angles are there in this place, if you can imagine. Okay, so this alpha, beta and gamma is there, and here what we see that the sides are equal. That means A is equals to B is equals to C. If you consider all the sides, three sides, see repeating sides in a cube, what is happening? This is very easy geometry you have learned from bachpan se. It is like this, no? Suppose you try to draw this thing. In this way you draw, no? This is the unit cell, suppose. So what are the various length, breadth and height is there? Suppose this is the height. Isn't it? And this is the breadth. Oh, sorry. Not that one. This one. This one, this one, this one, and this one. And these are the lengths. This one is the length. This one is the length. This one is the length. And this one is the length. So I hope you can understand. There are three basic sides. This one repeating 4 times here. This one, the length is repeating 4 times here, 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 and here. And the breadth is repeating 1, 2, 3, 4. So this, okay, this. 4 times the breadth is repeated, 4 times the length is repeated, 4 times the height is repeated. So basically there are 3 sides, length, breadth and height. If all of them are equal, it is a cube. Right or wrong? See, this is a small kid also will understand. And there are three angles between the basic sides. If this is the A side, then this is also the A side, this is also the A side, this is also the A side. If this is the B side, 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 and this is the C side, this is the C side, this is the C side, and this is the C side. So between A, B and C, the angles are alpha, like I have said here, alpha, A, B and C side. So the angles are beta, alpha and gamma. Okay, now if alpha is beta is equals to gamma is equals to 90 degree, definitely it is a cube. So such type of, definitely now you can understand that the types of unit cell will depend on these dimensions. Yes or no? And the first type you have just seen here, this type is known as the, what we can say, this type is known as the cubic system or cubic system of unit cells. Cubic system. Okay, or cubic crystal system. You can also say it cubic crystal system. No problem at all. You can call it a cubic crystal system also. You can call it a cubic system also. So that is the particular thing. Okay, now based on this dimensions, I will divide or tell you the types of the unit cells. Let us have a look over it. So this is the examples. You can take a screenshot of all these also. I will explain this also. So in cubic system, what happens? A is equals to B is equals to C, and alpha equals to beta equals to gamma is equals to 90 degree. You find this type of unit cell in copper, in NaCl, in KCl, in alum, in diamond, in zinc blade. Okay, so these are the examples are there. Now, where do you find it tetragonal? Now, how is the tetragonal and how does it look? I will show you how does it look. But at first understand that A is equals to B but not is equals to C, and all of them are equal to 90. So basically it is cuboidal. Okay, so in case of tetragonal, what will happen? Any of the thing, the C will not be equal. Little bit longer. Here actually I have drawn it little bit longer only. So anyway, in cubic all are equal. This is the cubic and this is the tetragonal actually, because you can see the C is little bit longer here. So or unequal or maybe little bit shorter. So in that case, I will show you how it looks originally. See, this is tetragonal. See, this diagram is tetragonal. See, alpha, beta and gamma all are 90 degree. They have shown all over the alpha, beta. Sorry, 1 alpha, 1 beta and 1 gamma you can see. Okay. And the angles, and the B is there and the A is there, which is equal, but the C is little bit longer. Can you see that? So it is a tetragonal unit cell which repeats itself. So the tetragonal we have understood. Again, after tetragonal, what is there? Orthorhombic or rhombic, where A is not equals to B is not equals to, none of them are equal, and alpha is equals to beta is equals to gamma is equals to 90 degrees. So this is also basically cuboidal only, but we call it orthorhombic. When A is not equals to B, means none of the lines are equal, but the angles are 90 degrees. So cuboidal, you have to call it cuboidal. Okay. So because it is a straight crystal, it's a solid straight crystal. When the, see, you have to understand, when the angles are being 90 degree, you will obtain this kind of structure, angles being 90 degree straight structures. Okay, straight unit cells. Okay, so I hope that you understand. And in the orthorhombic also, you just find that all the sides are unequal and the angles are 90 degree. This is how orthorhombic looks. All of them are unequal. A, B and C all are unequal, but alpha, beta, gamma are what we can say 90 degree only. So straight crystal only, but all are unequal. So I hope that you understand. So yeah, so in case of orthorhombic, here examples are given: KNO3, K2SO4, BaSO4, PbCO3, CaCO3. A lot of examples are given, which you have to learn. You can take screenshot and learn. Then there is monoclinic. Now this is going to be interesting. A not equals to B, not equals to C. None of them are equal, and alpha is equals to gamma is equals to 90, but not equals to beta. Beta is not 90 degree. So one of the angle is 90 degree. So I hope that you can understand. It will be little bit back. It will be little bit like this slanting. Okay, as because one of the angle will not be 90 degree. I'll show you how it is. So here you see alpha is equals to beta, they are 90, but gamma is not 90 degrees. So it will be slightly back where it is not shown here. Slightly it will be bent, like it will be little bit tilted because the gamma is not 90 degree. Okay, it will be, this side will be slightly tilted. However, A is not equals to, I think in case of monoclinic you saw that A is not equals to B is not equals to C, and one of the angle is not 90 degree. This kind of monoclinic does repeat itself. Okay, so in the crystal lattice structure, so that is the unit cell. So in this way we find triclinic. A not equals to B not equals to C, none of the angles are 90 degree. It will be purapuri beka. I will show you the structure. See, triclinic, purapuri beka, it is clearly beka. Then you find rhombohedral or trigonal, where all are equal but none of them are 90 degree. See, all are equal but none of them are, so basically it is all are equal, not none are 90 degrees. So it is basically a Beka cube, right or wrong, a tertia or a tilted cube, like this cube only, but a tilted cube. And then you find hexagonal. What is in case of hexagonal? A is equals to B but not equals to C, and two angles are 90 and one angle is 120 degree. So this data has to be remembered, this data has to be learned with the diagrams that I have shown, and the examples has to be learned. Okay, this is the diagram. Okay, this one is the cubic, this one is the tetragonal that you have learned, this one is the simple orthorhombic, this one is the monoclinic, and this one is the triclinic, this one is the rhombohedral, and this one is the hexagonal, and all the data are provided in this, and that is the type of the unit cell. So 7 types of unit cells, or 7 types of, you can say, crystal habits, or 7 types of crystal systems are there, because depending on the unit cell only the crystal lattice will form. How kind of, they will only why repeat. Okay, if they only repeat, if they repeats, they will form a particular crystal lattice. So this is 7 types of crystal lattices and 7 types of crystal habits or unit cells. Sir, why are you calling them crystal habits? I am calling them crystal habits because they only do repeat. These only do repeat. So in one of the crystal lattice, this will repeat, in another this will repeat, in another this will repeat, in another this will repeat, this will repeat, this will repeat, this will repeat, and form the entire crystal lattice. And it is just a matter of your imagination, that how you can imagine entirely the entire crystal lattice. You can imagine in your mind. So try to imagine that. But then a question arises. You must have noticed in these 2 pages that I have been flipping over to make you understand this. Sir, there are 7 types of crystal habits or unit cells, as you can say. But you can see, show us 14 diagrams here. Not 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 diagrams you have shown. 7 diagrams you should show, no sir? Why have you shown us 14 diagrams? So to answer my question, I will tell you one simple thing. Unit cells are of 2 types. Unit cells are basically of 2 types. Simple unit cells and the simple unit cells are also known as primitive unit cells. Simple unit cells are primitive, and the other one is non-primitive unit cells or centered unit cells. Now what is this? Let us try to understand. Now you had always imagined the unit cell is like this. Suppose, for example, I am taking a cubic unit cell only. Now you will think that the atoms or the particles are present in this edges or the vertices, right? In this, not the edges, these are known as the edges. Remember, these are known as the edges. Remembering the terms are very important, otherwise you will not understand anything. These are known as the edges, 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 okay, these are known as the edges, these are known as the edges, these are known as the edges. Now all the edges that you see, that are edges, and these are the vertices. Now you must have imagined that the units, atoms or the molecules or whatever is there, okay, so they are present here, present here, present here, present here. But actually the truth is they may be present in the face also, in the front face, in the back face, in the side face, in this, here in the face, here in the face, here in the face. So how many faces are there? 1, 2, 3, 4, pichone ekta 5, samne ekta 6 faces. On the 6 faces there can be 6 atoms. So this is known as face-centered. This is known as what? Face-centered unit cell. This is a new kind of unit cell. Okay, where you have to imagine that they are just not present in this structures. Okay, and then there can be another type where suppose this is the cubic cell, and this can be present possible for any other type of unit cell anyway, not only cubic. Now suppose this is the cubic one. Okay, I'm sorry for that. Anyway, now there can be a atom or particle just in the middle. Okay, just in the middle, in the machkhane, in the space. Okay, so that is known as body-centered unit cell. That is known as body-centered unit cell. Okay, and there is another one which is present just at the two ends. Suppose this is the unit cell. Okay, and just at the end, at the top and at the bottom. This is known as end-centered unit cells. So these are the new type of unit cells or the centered unit cell, and in which nothing, only the particles are imagined to have formed in the vertices of the unit cell, or imagined to be present in the vertices of the unit cell. Okay, they are known as simple unit cells or primitive unit cells. Now you will think then for the cubic type of structure, the cubic structure, there will be 4. Like you have in cubic structure there are 4, like you have shown here. No, my dear, I have just made you show here end-centered one to make you understand. In case of cubic unit cell, end-centered is not yet found or it's not seen. So in case of cubic system, you find only face-centered, body-centered and simple. Okay, so as simple as that. So that means 7 types of unit cells into 4 will give you 28 types of lattice structures. That is not true. You have only 14 types of lattice structures. Why? I have 14 types of lattice structure because I have 14 types of lattice structures because all the types of unit cells may not contain all the body-centered or end-centered or face-centered type of cubic units or the type of cells in them. Okay, for example, see here, in case of simple, in case of cubic, where alpha is equals to beta is equals to gamma is equals to 90 and A is equals to B is equals to C, it can be simple, it can be face-centered, it can be body-centered, but not end-centered. In case of tetragonal, it can be simple, it can be body-centered. In case of orthorhombic, it can be simple, face-centered, end-centered, body-centered, all the 4. So orthorhombic unit cell is the only type of unit cell where all the 4 types of that is centered unit cells, and the simple unit cell are present. Okay, and in this case they are not possible or not found. In monoclinic too, simple and body centered. In triclinic only simple is found. In rhombohedral only simple is found. In case of hexagonal only simple is found. So in total there are 1 2 3 4 5 6 7 8 9 10 11 12. Oh sorry, wrong calculation. 1 2 3 4 5 6 7 5 6 7 8 9 10 11 12 13 14. So 14, as I said earlier. Okay, so that is what I wanted to say. Please understand it carefully. Units, what are unit cells and what are the type of the unit cells depending on the dimension, and then unit cells can be again broadly divided into two types, that is our simple and non-primitive, okay, or primitive and non-primitive. In primitive, what you will think that it is present only at the edges, but then centered or face centered, body centered, end centered, and all the types of unit cell may not contain the atoms at their face or inside the body or at the end centers. So there are only 14 types. You will never do 7 into 4 equals to 28. 7 types of unit cells. 7 types of unit cells depending on their dimension, and all will have end centered, body centered, face centered, and simple, and 7 4s are 28. That is not true, but however this is true. That is shown in the diagram. You can take a screenshot. So I hope that you have understood what I have tried to make you understand. And yeah, so these are the types of crystal lattice habits that can be there. So we have basically stepped into the chapter solid state. Solid state is not a very huge chapter. It is a quite small chapter only. I hope that I will take either 3 or 4 classes and it will be complete. So I am sending you today part 1 and part 2, and there will be other parts also. But I will just say you why I am focusing the camera on myself is that, see, please see the video properly. You must have already seen, then only you must have come in this particular section where I am talking to you. You see, so in case of solid state, the overall thing I want to tell once that in solid state there can be 2 types of solids, the crystalline solids and the amorphous solids that I have discussed. And in case of crystalline solids, which we will discuss more in this chapter, little bit of amorphous also we will discuss later on at the end of the chapter. But in case of crystalline solids, what we have discussed here, we have discussed about the crystal lattice structure and the unit cells. We have discussed about various types, different types of bonding, okay, and different types of forces which are holding the particles of the solid together, be it a metallic solid, be it a covalent network solid, be it a ionic solid, be it a molecular solid, be it a polar molecular solid or a non-polar molecular solid or a hydrogen bonded molecular solid. There shouldn't be any confusion in understanding the differentiation, distinction and the binding energy part, and these things shouldn't be there. One conceptual question I want to ask is that if you think that binding energy actually gives us the idea, melting point actually gives us the idea that how stable a solid is, can you justify this statement? Yes, definitely melting point gives us an idea, because more the melting point, more is the binding energy, and hence more is the stability. So that point I want to mention, and I want to mention that for any crystalline solid which has a long range order, I hope that you have understood what is range order, the long number of repetitions, continuous number of repetitions up to a long distance. Okay, so that is the thing. Long range order, what happens, the unit cells repeat and form a crystal body or a crystal lattice structure, and there are 7 types of unit cells, and these 7 type of unit cells, all of the 7 does not contain simple. All of them can be simple, but all of them may not contain the atom at the body, middle of the body, so they cannot be, all of them cannot be body centered, all of them cannot be end centered, or all of them cannot be face centered. But however, if you distinguish the types of unit cells, they can be primitive unit cell, which is simple unit cell, and modern unit cells or non-primitive unit cells, which can be face centered, body centered or end centered, which through diagram I have explained you, which is the only type of the unit cell which can contains all the 4 types, that is simple, body centered, face centered or end centered, that is orthorhombic one. Right or wrong? That is the orthorhombic one. You must have seen it in the diagram. So please go. I hope that you have understood, and on Thursday you will get a new video. Thank you.